So I clicked.
Let me start sharing, right?
I mean, we can stay it for like as it is at the moment.
Oh, okay. Let me just go back there. Okay.
Okay, I think it started already.
Awesome.
So it takes the time actually to propagate. Okay. So welcome everybody. We are live here, so there will be some discrepancies here and there. You might be wondering, what am I doing here instead of Holger? And this is his fault. He decided to go like injection, so blame here. But who am I? I'm Jakub Jabłoński, and I will be your host for today. And with me, there is like Seyed Jafari. Sorry. I knew I will screw it. Sorry.
It's fine.
So, and we will talk about the other platforms here in a second. But in meantime, let me actually ask you, how long do you work with Kotlin? Like, what's your history with Kotlin?
Yeah, so first of all, hey everyone. I'm super happy to be here today. And yeah, so the story of me and Kotlin goes back to, I think, 3.5 years ago. So the journey wasn't always like a streamlined that goes from the beginning to the end. It was more of a roller coaster going up and down. but working with Kotlin is always amazing, and it's always fun to be involved in the community as well.
Okay, good to know. So let's maybe wait a little bit more here, and I want to give like opportunity actually to people to join quickly, and maybe in 1 minute we will start. Okay. So you are based in Berlin at the moment, I believe, right?
That is correct. I'm based in Berlin.
How do you like Berlin?
I like the city. I like the vibe, and as opposed to like a lot of other people, I kind of like the weather. It's kind of unpredictable, but I like it.
Yeah, especially today where we had like storms and I don't know, hail storms and sun in between. It was crazy today. Okay, so we are like 3 minutes through, and I believe we can start here. So Seyed, I wanted to say like stage is yours, but instead I will say that display is yours, right? So
thank you.
Have fun.
They're the same thing.
Yes, so have fun during the presentation. If you need anything from me, just shout out and I will magically appear, okay?
Awesome. Yeah, thank you. All right, just please quickly confirm if you can see my screen.
Yes, of course. It looks beautiful.
Awesome. Great to hear that. So yeah, here we are today, Kotlin user group, and we're going to talk about how we can travel between actually the worlds. It's actually happening right now as we speak, using the Kotlin multi-platform. Just a small self-disclaimer. So I've been talking to my doctor. Traveling between worlds is not advised for pregnant women and people with chronic diseases. So before you do that, make sure you visit your doctor. And jokes aside, let's get down to business. So who am I? Again, I am Seyed Jafari. I am a senior software engineer at Auto1, and you can find me by that and my handle and pretty much every social media you can find. All right. So a little theoretical lessons here. So what does exactly KMP mean? So KMP is a Kotlin language technology that allows you to compile your code for different platforms. And it kind of stands for Kotlin multi-platform. And long story short, as a user of this technology, what you will see is just the Gradle plugin, which we'll see just in just a bit. But now we are talking about platforms all day, but what is exactly a platform? So a platform is a system that runs your compiled code. And then if you ever heard about Kotlin, or if you ever attended a Kotlin event, you might have ever heard of a term called Kotlin Backend. So Kotlin Backend is kind of a compiler that compiles a piece of Kotlin code for a specific platform. I know it's like a very, very short and simplified version, but in a nutshell, that's what it does and stands for. And so now that we have Kotlin backends that can compile our code and we have platforms, let's see how many targets or how many backends do we have in Kotlin. To start, we have Kotlin native that can compile your code into machine code. Basically, for every CPU architecture that you can find out there, most of them, you can Kotlin backend is already supporting that, and you can compile your code for that specific architecture. So obviously, most of the known and famous CPU architectures and OS operation system architectures are already supported by Kotlin native. The other Kotlin backend which is very famous, and Kotlin actually started with that, is Kotlin JVM. So you can use Kotlin JVM to surprise compile your code to Java code. And one of the main use cases that I myself use it is for developing Android applications. But it doesn't stop you with Android. You can use it in desktop and other places. The next one, and last but not least on this list, is Kotlin JS. Kotlin JS allows you to compile Kotlin code and produce JS code that can be run on browsers and Node. So the idea of sharing code and running like a single code on different platform is not unique, and we are not the first people that trying this idea. There is still other tools that you can utilize to share your code, but some of the famous ones that is happening around the blog is Flutter with a language of Dart, and then we have React Native with JavaScript, and there is some dinosaurs among us like Xamarin and C#. No offense, but I don't think anybody is actually using that. If you're old enough, there is another technology called Cordova or PhoneGap, but I don't know if people attending this talk might actually ever heard of that. So, all right, we have those platforms and tools to compile or share our code or run our code on different platforms. Why do we need another technology? Why do we need to reinvent the wheel again? So I can come up with a couple of ideas that can help us to distinguish Kotlin from the others. The first and the foremost is Kotlin language. Honestly, Kotlin language is one of the beautiful languages that someone can work with. And don't take my word for it. A few years back, I think last year and the previous year, Kotlin won the most loving language of Stack Overflow survey. So it's not just me who loves the Kotlin. People around the world actually love that. And before we go any further, there are on the other side, we have Flutter and React Native. Flutter is with Dart, and there are people actually saying that Dart should not exist. Again, no offense. So we have a loving language and we have Dart. Let's go to JavaScript, and we have JavaScript with React Native. JavaScript is cool, yeah, but is it as cool as Kotlin? I don't think so. So interoperability and bridges wasn't a thing even from the beginning in Kotlin. So one of the things that sold Kotlin at the beginning of when it hit 1.0 was that there was no gap if you wanted to switch from Java to Kotlin. You could immediately do that, and you could have Kotlin code and Java code in the same package, in the same project, working with each other pretty smoothly. And then you going to the Kotlin multi-platform in specific, you get native performance using the Kotlin native, of course, but you get native performance as opposed to other technologies like Dart, like Flutter or React Native, which they have kind of a interpretation layer on top of your machine that runs the Dart code or React Native code. But with Kotlin Native, your code will be run on the CPU machine or on the CPU of your machine. That's why we have lots, as we can see a little bit down the line, we have lots of variety of compilers for Kotlin Native. So if that is not enough, Kotlin multi-platform is mainly focused on business logic code sharing, as opposed to the other frameworks which allow you to share, which kind of you have to opt in and share almost every part of your project, and having like a native code alongside Flutter or React Native is not the ideal solution. Kotlin, on the other hand, provides you with like a smooth interoperability. So, and it's folks at JetBrains are not pushing it to share like a UI framework code with KMP, and instead they're trying to make it a domain-specific sharing code technology. So that's there, and I think this is going to be the last on our slide. Platform support. So with Kotlin multi-platform, you can support tons of platforms as opposed to Flutter, which I think just supports desktop, recently desktop, and web and mobile, and React, which is mostly for web and mobile. With Kotlin multi-platform, you can support Linux, Windows, and other OSs, including even watchOS or how do you call it, WebAssembly. So a lot of room to even improve, or the diversity of platforms is a lot higher. All right, so far Kotlin multi-platform sounds cool, but why should we care? I'm already invested in Flutter. I'm already invested in or interested in React Native. Or I might be getting into the cross-platform with the other technologies. Why should I really care about Kotlin multi-platform in particular? To answer this question, please allow me to skip it for now, and I promise that we will get back to this question at the end of this presentation. For now, let's just see how we can set up and use KMP in our project or a new project. And then when we see the use cases, then we will get back to this question. All right, shall we? So before we start, for any project that we want to create, especially the Java project, you have a very strict project structure that you need to follow. And the directories, the packages, the build tooling setup, so they all have to be in a kind of a specific format and structure in order to work in harmony. Let's see one for example. So in a Java project, or in more specific, in an Android project, you have a single module, namely app, and then that application module, you have a file called build.gradle if you're building with Gradle. So and that one, again, if you're targeting Android, there's nothing super fancy. It's just a couple of plugins applied, and then configuring the Android plugin, and then dependencies. You apply the dependencies you want to use in your application. Now, with that in mind, let's see how does it look like if you want to add shared code using KMP to this same project. So again, let's first look at the code structure for project structure for our little tiny app. As you can see that nothing changed in terms of directory in the app module, but we did add another module to our project. For now, I'm just going to call it shared. If you look into the build.gradle for the application module, you can see that nothing really changed except that we added the dependency to the shared module. So nothing fancy is going on here. But when we open the shared module directory or the package, you can see that the structure is slightly different. So at the very top, we have SRC, which is source directory, and then right next to it, we have the Gradle build scripts. But inside, for Android apps, we just have a single directory called main, and that's it. Like if we go previous, we can see, not this one, sorry, this one, you can see that it's only main. But with the shared module, you can actually see that we have 3 directories going on. There are Android main, common main, and main. To give a short brief of what's going on here. So the Android main is where we put our Android code, and the main is just the package for our resources used in Android code. Probably in the near future, they will remove this necessity for the main package, even though right now there are ways that you can remove it. But if you just create a shared module right off the bat, you will see this main package directory. And the common is where all the magic happens, basically when where your shared code will be residing in the future. And don't worry, we will get into the details of each directory again in more details. For now, let's just look at let's have a look at the build Gradle script. So this is what it looks like. Of course, I'm using Kotlin DSL for this build Gradle as opposed to the previous one, but if you're using Groovy, nothing much will change. So on the top, if you notice, we are applying Kotlin multi-platform plugin, which is kind of a new plugin if you're new to this technology. And then right after that, we have the Android library, which is the common plugin if you are creating a library module for your Android app. Again, the ceremony of Android, we have the Android configuration block, which comes, it can be anywhere, but for me, comes usually right after the plugins block. And then we have this new block over here, which is for configuring that Kotlin multi-platform plugin on top and stating what we actually need from the plugin. So in the plugin, which we are mentioning that, okay, I need Android. And by need, I mean, I'm enabling Android target for the KMP and saying, okay, I will have an Android, specifically Android target, and I want you to build my share code and other codes for this target. So the target is basically the platform, but in a sense of Kotlin, in a sense of KMP plugin. And the next thing we see is the source sets. The source set we saw in the previous slides was actually defined here. So we have common main, as we saw it previously, and the Android main, which only gets activated after you enable the Android target for this module. And if you have dependencies, let's say if you have Android dependencies, they will go to Android main dependencies. And if you have like shared code library dependencies, usually they will go to common main. Again, we'll talk about dependencies later. So you can see again that those source sets we define, is exactly the same as Android main and common main that we have right in the project structure. What if now I want to add a new target to our shared module? I want to target a different platform other than Android. Just before we continue, I want to mention that I'm saying Android and in this slide iOS, but again, KMP is not just for Android and iOS. You can use it for desktop, and you can use it for backend. You can use it for all sorts of targets. But for the sake of simplicity, and since I've been working with the Android and iOS, this is going to be kind of a Android and iOS sharing code platform. All right, to continue, we are enabling iOS target because we want to tell the KMP that, hey, I want you to build my code for the iOS platform as well, namely for the iOS target. And then in the source sets, on top of the other source set that we have, we can add the iOS main source set, and then we can say, all right, here are the dependencies that I want you to use for my iOS artifacts that you're building. And the next one, we can see that after we enable the target, iOS target, we can actually have the iOS source set in our project. It's again iOS main, same project structure, like the same packaging, your normal Kotlin packages, and then the classes. All right, so let's talk about a secret that is going on here. So I kind of lied in the previous 2 slides to you. So I said we enable iOS target using the KMP, but that's kind of a lie because there is no iOS target. As we said, we have Kotlin native for the native architectures. I'm sorry, for the native code for the CPU architectures. And iOS is none of that. And instead, what is going on here is actually iOS function or target is kind of a convenience method or a helper method to set up all the iOS architectures that are out there. So we have iOS x64 and iOS ARM64. With adding just one function, we are kind of adding both of them to our project. And we're asking KMP to build for both of them. And if we add like any of them individually, we can also add their source sets individually as well. And of course, we can have the source sets in our project structure and directory. So, right, iOS is a helper function or helper method, but how can we have a source set for that? If it's a helper method, it doesn't get to have a source set for itself. There is a kind of a cool feature that added since Kotlin 1.4 that enabled you to create a hierarchical project structure for your shared code. That's kind of a mouthful name for a simple thing. So let's go through it. I said at the beginning that every code that you want to share with other platforms will be residing in common main, right? But on top of that, we can have a code that is shared between only 2 platforms. In our case, is going to be iOS platforms. And then we can, at the very, very bottom, we can have their architectural, the architectural specific targets and source set for each of the iOS architecture that are out there. So what this feature allows us is that we can have like most common code in the common main, and then if we have a code that just belongs to iOS, we can put it in the iOS main. And then if the code has to be specifically for a specific architecture of iOS, then we can put it in its architecture source set. So that's what hierarchical project structure looks like. And it's not just for iOS. You can use it with Java, you can use it with other native platforms. And in just a few slides, I'll show you how we can actually use it with other platforms as well. So now you can see that I enabled iOS, and then the other and the specific iOS architectures targets, and you can see that Kotlin block allows us to configure iOS main source sets and iOS architecture source set, and you can add dependencies based on what kind of library you're adding. So to kind of elaborate on this hierarchical project structure, you can see on the very top we have common, and then we have concurrent on the right. And the reason for that is that JS is kind of a single-threaded language, so you cannot go concurrency. So if you want to share code between other platforms and JS, the only place for that is common. The next level will be concurrent, because then we have Kotlin native and JVM, because JVM is not native, it's for the JVM, but it also supports concurrency. And then the tree goes on and on until we actually reach the very bottom, which is the architectures for every CPU of the natives. So at the very bottom, you can see that I have iOS, but that's not actually the rock bottom. There is one below, as we saw, which is the CPU architectures. All right, so now I said KMP can support quite a diverse range of platforms. And by that, I mean it's JS for browser and Node. Let's quickly run through them. We have JVM. You can write KMP code that targets JVM. Android. Surprisingly, Android native architectures can be supported by the Kotlin multi-platform or Kotlin native backend. And you can actually code that if you don't like C++. And then we have iOS architectures. These are part of the Kotlin native backend. iOS, watchOS, tvOS, macOS. I think we already listed all of the Apple products. And then we have Linux, Ming, I think Ming W. How do you spell that? I don't know. Sorry, Microsoft, if I butchered the name. And WebAssembly, which is the new kid in the block of KMP. They're actively working in this WebAssembly. As a matter of fact, they just announced that they are hiring, JetBrains is hiring people to work on WebAssembly. So try them out if you're interested. All right, so cool. We saw how we should structure our code, but how do we really, what can we actually put inside? So let's see what's going on in this class in our common main. As you can see that it's a class in the common main directory. So every one of the targets or our platforms will be able to access that. And there is nothing very fancy going on. As I said, this is going to be a first sample app that the Visa will create for you. It's a simple hello world, but with the platform a specific name. And if you run this code, if you call the greeting function, you will see that it will print hello Android, hello iOS, and so on and so on. But how is it really happening? Let's see what's going on in the platform class that we have. Again, it's in the common code, and this is the implementation. This is actually interesting because nothing is inside this platform class. It's kind of empty. It's just a class with a simple property called platform, and that's it. So I asked myself, all right, wait a second, where is this magic happening? I mean, where are we getting the Android key? Android string? Where are we getting those the iOS string? Where are they coming from? So to explain that, to explain that, we have to focus on what that expect keyword mean in Kotlin. So in Kotlin, we have a expect an actual keyword that allows us to kind of expect an actual. But but to explain them, we can define behaviors and classes with expect, and then implement them using actual. So with expect, if you're in a common in a common code and you need a class or a kind of a behavior, you can define it using expect. But because that behavior or a class depends on the target like capabilities or features, you cannot really implement it right there. So you need to implement it in the target specific directories. So with this expect keyword, we say, hey, Kotlin backend, I need to get this code from the architecture specific directory. Go find it there. You will see it there. And in order for the Kotlin native compiler to, or the KMP compiler, in order for the KMP compiler to find your actual code, you need to have the same class, but with the keyword of actual pasted just before the name of the class or the behavior. So right there rings a bell. We have seen this behavior before. It's not new to Kotlin. We have interfaces in Java or in other languages like Swift. We have protocols. They do almost the same thing. So we say, I have an interface. It has these behaviors, and this class has to run with that interface. What is the difference? To me, the difference is that interface doesn't have an state. Interface is not implemented. Interface is not completed. It's like a plug and play way to kind of pattern to structure your code or to architect your code. But with expect and actual, in the common code, you have the ability to have a state for your class. And in common code, you expect that this class will have a value in its property instead of like the interface, which is like stateless. In interfaces, you don't see any states. So that is the main difference between expect and actual. Now, all right, we see that there's expect there, and right there we are expecting to see some actual code as well, because as we just said, for every expect we need an actual. Where did they go? So if you remember from previously, we had two targets, Android and iOS. So for Android, we put the platform class in the Android directory, and we implemented using the Android SDK classes. So you have the actual class platform, and then I have the actual platform property, and then you implement it. The best part is that we are in the hands of JetBrains tooling. So you don't really have to go through each of your platforms individually and implement them. With a small option enter, or if you're on Windows, Alt enter on the common code, expect common code, you can implement them, all of the actual code immediately, at least the boilerplate. For the iOS, the story is nothing different. So we have the iOS main, we have the platform class implemented, and inside, again, we have just the actual class and its small parameter. Just a small note that you can access iOS classes, I think they're called UI kit, if I'm not mistaken. No, foundation. And you can access those codes in the shared, in the Kotlin iOS main directory. There are sample codes out there that you can see and use that if you're interested. But to elaborate on what we have discussed earlier, this code will be shared again for the both architecture of iOS. ARM64 and x64. If you want to go like more granular implementation, you can actually remove this platform class from the iOS main, and then instead add the platform class to each architecture specific directory. That way you will get like the fine grain control over how the code will be like behave. A small hint, if you are adding a target to your KMP, make sure you add even empty directory of that target to your project. I have had some small problems before. I don't know if they are fixed or not. But if you don't add the empty directory, the KMP plugin won't recognize the project as set up for that target. So just be safe, add the empty directory for that target. Even if you don't want to put any code in there, just have it in your project. All right, so now we said we can put write or put our shared code, the code we want to share with other platforms, in the common main directory. But we are living in a year of 2021, and no one, I guess, goes out and build everything from ground up. We are using libraries, we are using SDKs, we are using helper methods. We're using the platforms to its maximum in order to deliver products, the better products. Do we really have them in the common main? The answer is no. Unfortunately, you cannot access any of the features that you have in your platform-specific directories in the common main, of course, because everyone has to know about it. So some of the use cases that are very common and they don't exist in the common main are databases. You don't have databases. String manipulation. Oh boy, this one is hard and kind of doesn't exist. Serialization and deserialization of JSON and XML or any form of serialized format. Threading. It doesn't even exist for a specific platform or JS. So there is no notion of threads in the common main. File IO, this one is the last stand of libraries missing from the common main. It doesn't exist up to today. UI frameworks, as I said at the very beginning, JetBrains is kind of providing this technology for a business logic. So there is no real UI framework to support the common code. Networking, there is no notion of network in the common main or in the common code, so you cannot really call a network API in the common main. Last but not least, which definitely blew my mind, I really didn't expect that date and time be depending on my platform. I mean, seriously, they are like the baseline of every project that you start building, right? But unfortunately, they don't exist. Am I really being truthful with you? Not really. Some sort of. So again, this technology belongs to JetBrains, and JetBrains are good with the tooling and libraries and plugins. So, and most of the main functionalities that you need in the common main is already been provided either by JetBrains or the community. So for database, you have SQLite, my favorite, and the Realm, which is, I think, the new kit. They just announced it. So you can use these two libraries in your common code, and you can target, I think, almost all of the main platforms, I guess. The next one is string manipulation. So this one, thanks to the Kotlin team, they baked it into the language. So you don't really have to add a library in order to just, let's say, call dot substring or dot to uppercase. It's already been baked into the language, and you can benefit from that. Kotlin serialization is one of the best libraries to support to serialize your objects and to JSON. I think they are supporting protobuf recently as well. It supports common sharing code, so you can use that. For threading, again, you have reactive and coroutines. Coroutines is not really a multi-threaded library when you get to the Kotlin native land. They're working on that, but because of the limitations that I'll talk about in short, you have to do tricks in order for the coroutines to work. But reactive is already there and you can support it. But keep in mind, they are not working in a multi-threaded fashion in the JS platform. File.io, we have OKIO from Square and Kotlin but they're not completed yet. It's a work in progress, so shout out to them and start a project so that they know they have to work on it faster. UI framework, again, I kind of lied because we have Compose for Android, desktop, and web recently, and Swift UI for almost all of the Apple products. So Compose on desktop actually runs on JVM and web. So I don't really want to call that a common sharing library. For networking, we can use Ktor client, which is very, very powerful and gives you a lot of options to configure. I honestly haven't had any problems, and it actually integrates well with the existing libraries, or let's say OKHTTP or other library that you're using right now. Datetime, my concern, it actually just released by JetBrains. So they have a library, Kotliners datetime, and it's kind of a fantastic because it supports time zones as well. But no technology is cool without a test. So no test, no gist. But you're in a good hand. Kotlin multi-platform supports testing as well. And Kotlin provided a small library that allows you to write shared tests that can be run on almost all of the platforms. So you can have by adding this library, you can have a piece of test in a style of XUnit test, let's say JUnit test, and KMP will compile and run that test for each platforms. The caveat here is that usually with XUnit test or JUnit test, we expect it to be super fast because it's running on my machine and I have a powerful machine. I need it to run quite fast. But because KMP has to compile your code for lots of architectures and native ones, it's not going to be as fast as you expect it to be. So you need to kind of tune your CI if you want to share your, if you want to run your shared tests on all of the platforms. Otherwise, the less platform you support, the less overhead it has. But if you are, sorry. All right, we finally to the next slide. But if you are really, if you want to test just target a specific code, you can just add the library to that target and just use the tooling in that target test. Please notice that I'm using common test and iOS test. So every target that you add has a main and test postfix for the directory. So main is for the real code that is happening, and the test is for the testing code that you have. So Android test, iOS test, JVM tests, all of them is supported. All right, so I did already give a hint about Kotlin native and its limitation on running like multi-threaded fashion. But what's going on? So with if you want to support architectures, the CPU architectures, and you want to run your code on a machine level, you have to bring everything you got in terms of running the code, in terms of memory management. Everything has to be bundled. So Kotlin native has its own memory management built right into the language for you, but the memory model or memory management of Kotlin native is not, let's say, not the best, or it sucks. Sorry, JetBrains folks. The thing is, memory model of Kotlin native is tricky, hard to grasp, and it takes time to get used to. The most thing that you might face when you are coding for Kotlin native is this little fella. You will see invalid mutability exception quite a lot, but there is a small hack that you can actually avoid it. If you go fully mutable and single threaded, you will not see this exception quite as often. There are small places that it can happen, but usually you will not see them happening in your code. But since this is happening quite a lot, this exception can be thrown almost from any part of your code. Somebody called it like the next $1 billion mistake. So they put it as a brother of null pointer exception now. All right, but this is not the end of the story. JetBrains announced, or Roman announced, that they are working on it. They have the new ideas for memory model, especially on Tuesday on the Kotlin event. They said that they're expecting the developer alpha version of the new Kotlin native memory model to be released for everyone on December, September, around the fall of this year. So fingers crossed. Let's see if that really happens. Hopefully, with the new memory model, lots of problems will be fixed. All right, so we talked about how we can code. We talked about how we can test. It's time to publish. Publishing for each platform has its own story. So if you want to publish for desktop, I think you need the right plugins. For Android, we have the Android Gradle plugin, but for iOS, JetBrains already supported us with KMM plugin. It's an IntelliJ IDEA plugin that helps you when you want to like share your code within Android and iOS. It's just focused on mobile devices. The name actually stands for Kotlin Multi-Platform Mobile. So if you hear it around there, they are talking about a subset of Kotlin Multi-Platform that is just focused on mobile platforms. This plugin is so good, and it helps with a lot of aspects, including debugging, publishing, setting up. So if you want to target iOS, definitely check it out and don't let it slip. The next one is CocoaPods and TouchLab CocoaPod extension. So there is a CocoaPod plugin for KMP that you can that allows you to bundle and ship your iOS targeted code as a CocoaPod, and your Xcode can actually resolve the code. But it doesn't stop there. We have Swift Package Manager, which is like the official package manager for Swift from Apple. There is support for that. With a little setup, you can actually set your code up and running with SPM. And there are tons of samples out there which you can have a look. I'll have 2 samples at the end of this presentation which you can rely on. All right, folks, we talked about Compose Desktop. It's not fair if we don't talk about how to publish. Actually, Compose for Desktop has its own task for publishing. So it's quite straightforward. On the top, you just give your main class and native distributions. Either it's Windows, Linux, or Mac, and it will just build you an artifact. How cool is that? You will get on Windows, you will get a .exe, or on Mac you get a .dmg. Straightforward, nothing so fancy. All right, so now we know what is the KMP, but and how to introduce it to our project. But is it really for greenfield applications or for brownfield applications? Who can really benefit from KMP? To give a short explanation, greenfield applications are the apps that you start from the beginning. Like there's a new startup happening, you have a new project idea, and you want to start sharing in them. And brownfield is the project that is already up there. Let's say your company's project, it's been built 5 years ago, and you want to introduce KMP with that. So if you don't have a luxury of greenfield project, you can still use the KMP. So in a greenfield project, you can just right up front, decide and change your project structure in order to maximize code sharing. So if you want to just put every part of your code into app module, if you're an Android developer, just pull out the Kotlin part of it or SDK agnostic part of it and put it in the common code, and voila, you got sharing code. That's it. So for the greenfields, it's quite easy to get up and running. But for brownfield project, you can start and sharing your code in the next feature that you want to add, or if you're maintaining some part of your project and you want to introduce KMP, that can be a good candidate because you're the maintainer of that domain. You know a lot about it, so it allows you to kind of pull out the code and put it in the project structure and start sharing. The next one can be the tests or bug fixing. Again, if you know what's going on, you can actually pull out the code and start sharing for those specific. I'll get into details on what can be a good candidate on when we are introducing KMP to our project. So we said that we want to share, but there is no technology addition to our project without concerns. So every technology, every hype that is out there has its pros and cons. We already discussed some of them, like let's say tooling. So we said the tools might not be the best. So, but JetBrains is already like working very hard to provide the best tooling. IntelliJ IDEA and Android Studio already support KMP pretty smoothly, so you don't have to worry about it much. And we are in a good hand. And even Google is kind of investing in this area. The next one is libraries. As I showed, that there are quite a lot of libraries already out there, and they kind of support you building mainstream apps. So you shouldn't really worry about the libraries, except that you have a very, very specific use case that is not very common for everyone. The next one is the boss fight. How do we convince our friends to get along with us and allows us to like share the code? So let's say that you're developing an Android application and your company has a brother's iOS application for that app. How do you convince the iOS team to start using your code in their app? That's a good one. So convincing people can be much harder than just introducing a new technology. So before you start working on a technology, you need to have a plan. I don't say that it's not doable. I say it's challenging. And if you're up for the challenge, you can definitely win it. I'll just go through companies and ideas that can help you to convince your teammates in order to start sharing your code or your Android or Java code with them. So the first idea is that have a real proof of concept. All right, so in your project, you have a lot of domain-specific logic. Let's say you have a logger, you have analytics, you have backend syncing like repository, you have core business logic, like a small class that is like your core business, and it applies a couple of logics to your domain classes. Part of the networking, so you have a networking system in your application. I think pretty much every application has a networking layer. So that's a good concept. And before you actually start convincing your teammates, have the code ready. I mean, pull out the code, your logger again, or your business logic, or whatever part of your code you need, you're interested in sharing. Keep it as small as possible. Structure it in a sharing way and have it ready before even you start talking to your teammates. Keep in mind that you can take an unfair advantage over your teammates if you directly target the the bottlenecks or cases that can be hard to implement, or you already implemented it, or they have bugs in that area. So if I want to have advantage over my teammates, I would just implement, I would just share the code that is directed to those areas of our project. The last and but not least is talking about other people or companies or teams experiences. There are a lot of companies out there already support using KMP in their project. PlanGrid from Autodesk, Cash App from Square, and Kareem, a ride-sharing app, already investing on KMP. Read their story, see how they they convince their teammates, and maybe you can get some ideas from them. All right, so now that we have the ideas, where are the samples? So I have two samples here. Rion is the first project. It's actually my side project I've been working on with a couple of friends. And it's quite a large project, I must say. The Android version has been released, quite a fancy one. Go and check it out. You can check KMP code everywhere. I think we are sharing, more than 80% of our code with iOS and Android. And we are planning to support JS as soon as possible if we have the capacity. People in the space from Handestam Sam, I hope I'm not butchering his name. It's a phenomenal GitHub repo. Check it out. It supports almost all of the platforms that Kotlin multi-platform supports. So it's a good one, and it's super easy to start reading Kotlin multi-platform setup. All right, I promised at the very beginning to talk about, is KMP useful for we or for us? To talk about this one, I would say we kind of answered this question along the way when we were talking about its use cases or where we can apply. But to reiterate is that KMP, the best part about KMP is that you shouldn't really shift your mindset from your current setup. It's just, it will be just a little bit different on how you organize your code, how you package your code. If you have an Android app, all you need to do is just move a couple of classes to a different package, and that's it. You have a sharing code. So you can start sharing at your own pace, or at your team pace. And then if you see that, okay, sharing code is not our project or our company's thing, you can just stop doing it, and you don't really lose much because you're not going to throw away the code. It's not like Flutter that you will have to rewrite the code in Kotlin again. It's already in Kotlin. It's native for Android and iOS. And if iOS doesn't want, iOS decide, okay, KMP is not for us, you can just keep the code, and it will be just a slightly different package. That's all. So I highly suggest that you go out there, try it, especially on your side project, and see if it fits you and your company to use a KMP technology in your project. All right, that's it. Welcome to the new world. I must say that you're gonna enjoy the other landscapes, views, and the story is not finished. People are working on that. Happy Kotlining, and you can find me with that Twitter handle. That's it.
Okay. So it was a great presentation, Seyed. I really enjoyed it, actually. I should, do the slow clap, So I'm doing
Thank you.
So because you might not hear actually any other people around here. That's actually the sad story, right? That we don't see our faces anymore so much. Hopefully this will change soonish. So if you have like any questions to Seyed, please write them in the chat. We will stay online for a couple of minutes still, so you have a chance actually to ask some more questions. And in meantime, there was like some confusion in the chat. So you mentioned that there is like a compose UI, but how UI part actually translates to the sharing of the code, right? Can we share actually the UI part, or is it like possible to use like some common libraries actually to create UIs here? Maybe you can actually address this question here.
Yeah, sure. So as I said, the main purpose of Kotlin multi-platform is not to share UI. JetBrains is especially in the Tuesday event, they mentioned that they're not planning to build a completely multi-platform UI framework in order for you to share your code for mobile, web, desktop. But Jetpack Compose has been ported to desktop and recently to web. They're all for Android it's beta, for desktop it's alpha, the last time I checked, and for web it's even before alpha, it's developer preview. The code for that for Jetpack Compose can be shared between JS, JVM, and Android, but you cannot share it with Kotlin native platforms. And so Kotlin native platforms include iOS, Linux, or Mac OS, or if you want to directly target Windows. That's why I say sharing UI code is kind of a controversial thing with KMP. Make sure you know where you're going before you start sharing UI code with KMP, because it's super challenging, especially if you think that the domain of those platforms are totally different. Let's say the way the user experience on mobile is completely different from the user experience from the desktop, and they're all different from JS or the browser world. So make sure you know what you're doing, and definitely check out the Jetpack Compose. Maybe that solves your solution. Did I answer the question?
I think in a way, yes, but maybe like let me reiterate. So from my perspective, the way I understand it is that you should share, the logic mostly, right? The models that you have, the I don't know, even if how you download or interact like with the internet or something like that, but not necessarily the view. The views should be actually platform specific, and the reaction, right, should be like a platform specific here. So this is the way I understand it. But I guess you could, in a sense, abstract the views as well, right, and use your own abstractions as a common module, right, and implement those abstractions, right, in each of the platforms. I'm not sure how useful would that be, but I guess this should be possible as well, right?
Yeah, exactly. That's exactly what I was trying to convey. And yeah.
Okay, awesome.
I think you're muted.
Yes, I was muting here. Like, unmuting yourself is hard. It's the 21st century, so all of us have a problem at the moment. Is there like any other actually questions? Let me check quickly here the chat. I see one question here. Let me read it out loud here. So when we have a shared code, how we can share it across the platforms? Do we give some kind of compiled file like jar or wherever, or they have to use IntelliJ IDEA? So I'm not sure, like, if you understand the question here, but
I got some ideas.
I'm
gonna try. Hopefully this time I'll succeed as well. So I think the concern is that how do we like after we have the shared code, how do we publish and give it to the other teams? So if you're sharing for Android target, you can build an AAR and just put it in the Artifactory or Maven Central. If you are sharing for targeting to a JVM, you can build a jar. And if you're sharing for iOS, you can have a framework that you can host it in, let's say, CocoaPod's repository, or again, you can have it as a Swift package manager. So since it supports pretty much all of the common standard artifact types, you can follow the main streamlined processes for publishing your share code. There are actually beautiful talks from Ben Weiss. No, not this name. I'm gonna share the link later. That the people in companies of Square and Autodesk, they go into very depth of how they are publishing their artifacts between the other teams, and they are sharing and publishing between iOS, Android, and desktop. So that might be interesting for you. Definitely check that talk out. Hope I got the answer. If I'm not, please repeat the question and we'll try it again.
Okay. So I see another question. Which targets are production ready, from Alex?
That's a good one. All right. So about talking about production ready is kind of controversial these days, because we have a lot of alpha released libraries that we are using in our projects. So Kotlin native backend is alpha. So that includes KMM or Kotlin multi-platform mobile or the iOS sharing land. But JetBrains team have said like a million times that you can start using Kotlin native in your project, and it's pretty stable, promising, and we are building tooling around it. So the idea of alpha is that they are not sure about the internals, but they will not change anything that will affect your project like drastically, that you will regret it. They have said it quite confidently. So and plus on top of that, with Kotlin native, as I said, like a lot of companies already invested in it, including big companies like Square and Autodesk. So I cannot say that it's not production ready, but because of just that alpha name in front of it, it's hard to say it's absolutely safe. You can use it. That's what I can say. With Kotlin JS, they say, I'm not sure the status, but I think it's more stable than the Kotlin native. So you will get more stability with Kotlin JS than Kotlin native.
Okay, awesome. Actually, I missed one of the tricky questions. I believe it was answered already in the chat, but let me, ask here as well openly. So, do we need actually Mac machine to build the iOS application?
Sorry to break it down to you, but it's Apple, and if you want to enter the Apple world, you need a Mac car. Unless if you have a Mac machine, yeah, you cannot really develop or deploy or even target iOS platform, or even Mac platform. So if you want to target those platforms, you need.
But is there a way, for instance, to have like a virtual machine or for iOS or something like that to just build it there, or there is no way?
There are ways. There are ways that you can.
It might not be legal, right?
Yeah. I'm gonna say that it's not legal. I'm gonna be super transparent here, but I don't say that it doesn't exist.
Yes. Okay. So let's go further. What can we see here? So there's like another question. Can we use Gradle for all of them or not? So I assume that the question is about all the platforms. There is like a second question to it, or should we actually use other platforms like Docker So I guess this is about the platform, like if we can use Gradle for all the platforms here.
Yeah, so for building the code, Gradle is a good, good candidate. I'm not sure they are supporting Bazel or Bach or other build system, but for building your code, Gradle is the right tool. And it supports all of the platforms. And as I showed in my slides, you can just keep adding targets to your KMP plugin, and Gradle will just command Kotlin Kotlin backends to build the code as necessary. But for running those build code, it's a different story. So let's say you're sharing code to target Android, then obviously you need an Android device to run the code. If you're sharing code for the server side, then you need, like, if it's Java, then you need like Java compatible server to run the code. Same story with JS. So if you're sharing code to target Node.js, then you need a Node.js server to run the code. So there are two aspects to these questions: how to build it, definitely Gradle, and how to run it. It depends on your platform.
Okay, so let's maybe wait like 1 more minute before we actually stop the stream here. Maybe there will be more questions appearing.
Okay.
So okay, I'm not sure if there will be like any more questions. So I would like to thank you, Seyed, once more. It was lovely presentation. I've learned myself a lot. Although I was using KMP in very early days, it changed actually a lot, to be honest. Like it evolved very much. So it was very fun actually to see how it evolved, at least to me. I hope that all our viewers as well enjoyed it. There is like a lot of thumbs up actually in the chat as well, and waving. So I believe everybody is happy here. So thank you very much once again, and hopefully we will have like another talk in person in Berlin. But let's see if this will happen. Hopefully we can start organizing, maybe in 2-3 months, something, maybe after the summer, the situation will be better. So see you on our future Kotlin user group, and thank you very much once again.
Thank you so much for having me. It was awesome to be talking Kotlin especially. And if anyone has a question, just reach out to me on Twitter or any other place that you can find me. Again, happy to be here. Thank you for being such a wonderful host.
Thank you very much. So have fun, people, and see you next time. Bye-bye.